Unit 3, Lesson 12 notes are going to be about independent events. We're going to be dealing with problems that are and. Lesson 12 is going to deal, both Lesson 12 and 14, we're going to do one thing in between, deal with and problems. This section is going to be for independent events, and Section 14 is going to be on dependent events. And there's a pretty large difference with how you're going to do them. So your number one job is going to be to determine whether these things are independent or not. So in an independent event, the occurrence of one event does not have an effect on the probability of the other. So for instance, if I roll a die and I get a number, get a 6, whatever it is, then I pick that die up and roll it again and get a 4. It really has no bearing whether I rolled a 6 or a 2. Me getting a 4 is, me getting a 4. I draw a card from a deck and I get a queen. I replace it, and then I draw a second card and I get whatever that card is, whether it's a queen or not. That would be an independent event, because when I put it back in the deck, there's still the same 52 cards in there. I could get that same card or I could get a different card. It's still going to be the same probability. So when two events are independent, the probability of both of those occurring would be to take those two things and multiply them together. So in the previous section, when we did OR stuff and it was addition, and is going to be multiplication. All right, so first example, flip a coin or roll a die. What's the probability of getting tails and a 6? So the probability of getting tails is 1/2. I then take and roll a die, which has no bearing on what happens with that, and that would be 1/6. I'd take those two and I would multiply them together, and that would be 1/12, which, if you put that in the calculator, is approximately 8.3%. And think about it. If you flip a coin and you've got heads or tails, and then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. There's a total of 12 possibilities, and out of those 12 possibilities, getting tails and a 6, there's only that one possibility. That's why it's 1 out of 12. Just another way of looking at it. And in a 52-card deck, what is the probability of drawing a jack, replacing it, and then drawing a diamond? So take that first card, pull it out, probability 4 out of 52. Take the second card, put that one back. So that means I'm still going to have it out of 52. And now I'm trying to get a diamond, so there would be a 13 out of 52 probability of that. And if you multiply those two together, you're going to get 52 out of 50 over 52 squared. But you can do this however you want to in the calculator. 4 times 13 happens to be 52. So when you put that in, it's going to be approximately 1.9% when you do that. The way that I would type that in, 4 divided by 52 times 13 divided by 52. Okay, there's your 1.9%. All right, next stuff. Container has 3 red markers, 2 green markers, and 5 blue markers, so a total of 10. A marker is drawn, replaced, and then another is drawn. So like I said, when we do section 14, we're not going to replace it. What is this probability of selecting 2 blue markers? So to get a blue marker, the first one, since there's a total of 10 and 5 of them are blue, I'd have a 5 out of 10. Put it back. That means you still have a 5 out of 10 chance. Multiply those two together, you're going to get 25%. There is no real reason to take these things and reduce them. And as a matter of fact, I would highly recommend you don't. In your head, to multiply this together, that's 1/2 times 1/2, which is just 1/4. But writing it, I would write it as it is and not bother reducing. All right, 1 red, which would be 3 out of 10, and 1 white, which would be 0 out of 10, because there are no white ones. So 0% on that. 1 red, and then 3 green. So green is 2 out of 10. So each time, because you're putting it back, it is 2 out of 10 for each one. Put that in the calculator, you're going to get 0.24% approximately. I would typically, I would go one or two decimal places with stuff. If this number is a zero, I usually write two decimal places after it. And if it's, 1, 2, 3, 4 or something that's not zero, then I usually just go one decimal place. All right, and the last thing you're going to have in here is probabilities for at least one. So when you're doing at least one problems, it's easier to do the complement, which we talked about a couple of sections ago, and then subtract the answer from 100%. So remember, the complement is the opposite. So if you have a 40% chance of doing this, you have a 60% chance of not doing it. All right, the game is played by drawing 4 cards from an ordinary deck and replacing each card after it's drawn. Find the probability of winning if at least one ace is drawn. So if I'm drawing 4 cards, that means I would need to do the probability of getting 1 ace, 2 aces, 3 aces, or 4 aces. Well, that's doing the problem 4 times and then adding all those answers together. That's kind of a pain. Well, you have 5 possibilities when you're drawing this. You could get 0 aces, 1 ace, 2 aces, 3 aces, or 4 aces. And if I want at least 1 ace, that would be all of those. Well, the only thing that's not in there is the 0. So since these are the only possibilities, putting all of those together adds up to 100%. So why not just find the probability of getting no aces and subtracting it from 100%? So that's what I'm going to do here. So I'm going to do 1 minus no aces, and because I'm putting the card back each time, that would be to the 4th power. So that would be 1 minus, so no aces, so there's 4 aces in the deck, so means there's 48 non-aces raised to the 4th power. If you put that in the calculator, you're going to get approximately 27.4%. All right, a coin is tossed 5 times. Find the probability of getting at least 1 tail. So again, if you toss a coin 5 times, you could get 0, 1, 2, 3, 4, or 5 tails. I'm looking for that. Let's use 1 minus that. So 1 minus no tails. And with these at least one questions, I do this almost every time. I write out what it is so I don't screw it up. And because I'm flipping that coin 5 times. Now, I can do this just like on the last problem, is because it is an independent event. If this is a dependent event, this doesn't work because now each time this number is going to change. Like if I'm drawing a card, if I don't place it, it's no longer going to be out of 52, it's going to be out of 51. So you wouldn't be able to use this idea. Okay, nonetheless, 1 minus not getting tails, that'd just be getting heads, so it's 1/2 to the 5th. And that is going to be just short of 97%. All right, that's lesson 12 from Unit 3. Let me know if you got questions.